Okay, let's continue this full moon example. In the previous video, we have talked about how to conduct hypothesis tests for pair data. Now let's see how we could construct a confidence interval for the pair data. So the formula is like this. Again, it's very similar to the one population that confidence interval that we have seen before. The only difference is we are replacing the y bar and s using the d bar and sd. So the 99% confidence interval that we are trying to calculate using this formula, d bar plus or minus t times sd divided by square root of m. So we are again using the last line, the data from the last line. D bar is 2.43 plus minus, and t, let's leave it here, 1.46 is the SD divided by square root of 15. This t value, you should have already know how you could find this, but let me draw the graph again. So suppose this is the t distribution. The 99% confidence interval means the area in the middle is 99%. So the area on two extremes are going to be 0.005 each because they are symmetric. So we want to find uh, 0.5th percentile or 99.5th percentile for a t distribution with degrees of freedom equals 14. So it's still a t distribution with degrees of freedom equals to 14. Using the table or the stat crunch, we could have this is 2.98. So this t value here is 2.98. So we will have 2.43 minus 1.12 is the lower point, 2.43 plus 1.12 is the upper point, which is 1.31, 3.55. This is the confidence interval. And how we would interpret a confidence interval? So we could say we are 99% confident. We have talked about this when we are talking about confidence interval. And I hope you guys still remember that, we are trying to make phone calls to our grandma during that case. That is when we first started this online Zoom thing, I'm trying to call my grandma. So we are 99% confident that the true mean difference, again, we are focusing on the difference in number of disruptive behavior for dementia patients at this hospital. As I've mentioned, you have to be careful when you are trying to make a conclusion about the entire population is somewhat between 1.31 and 3.55. Or you can also actually interpret more about what is this difference. So you can also say that we are 99% confident that the number of disruptive behaviors for dementia patients is somewhere between 1.31 and 3.55, higher for the days surrounding the full moon than other days on average. These two interpretations are basically the same thing. You're just explaining a little bit more about what is the difference here. Okay, so this is the end of the video.